Java Reflection is a powerful feature that allows a program to inspect and manipulate classes, methods, fields, and constructors while the program is running. In other words, you don't have to know everything at compile time. Reflection lets your code look at itself and adapt dynamically. With Reflection, you can explore class information such as names of methods, fields, and constructors. You can access and modify fields, even private ones. You can invoke methods by name, and you can even create new instances of objects on the fly without writing their types ahead of time. Reflection is widely used in real-world scenarios. Frameworks and libraries like Spring, Hibernate, and JUnit rely on it for dependency injection, database mapping, or test discovery. Tools for serialization, such as Xin or Jackson, use Reflection to inspect and convert objects. Even debuggers and profilers make use of Reflection to analyze running code. Here's a quick example. Imagine we load the ArrayList class at runtime. We can list its methods, create a new ArrayList instance dynamically, and even invoke its add method to put in the string hello reflection. When we print the result, we see that the ArrayList contains our new item. All of this happens without writing direct references to ArrayList in advance. Of course, Reflection comes with advantages and disadvantages. On the positive side, it gives flexibility and enables powerful frameworks. On the downside, it can be slower than direct method calls, may introduce security risks since it can access private members, and it bypasses compile time type checking. In summary, Java Reflection lets your code explore and modify itself at runtime. It's a core technique that makes modern Java frameworks work, but it should be used with care. If you found this explanation helpful, please like this video and subscribe to the channel for more programming insights.